Hello everyone. As some of you requested for kind of a solution for the data analysis 3, I just make this video for the details so that you don't get confused in the final exam. All right, so for data analysis 3, we use this JMP data file. So we just first download it. All right, so this is our data file. All right, so when you open this data file, you will see that there are many observations in this data file, right? And you have many variables in this data file, right? So first thing, always for a data analysis is always to learn about this data, right? Okay, so here is an introduction about all the variables, right? So first, the first variable is the ID variable. We know that the ID should not be a input variable in our regression or data analysis because it is just a ID, right? We cannot use ID to make the prediction about anything. It is just a random number. Right, so that's why the ID is the model row is just the ID. It is not a input variable. And then we have the inference, and then we have the age, we have the cluster group, right? So when we look at these two variables, one of them is rejected. In the introduction video for the data analysis 3, I say if you see the rejected variable, that means it has the repeated information with other variables in this data set. So very clear, it means that this variable has the repeated information with this variable, it just with maybe different format. So we cannot include two same variable in the data analysis. So this one is rejected. It is not an input variable in our data analysis. All right, and then we have the cluster group, we have the gender, region, TV region, and loyalty status, right? The class, the total amount spent, right? And then the time as the loyalty member, and then we have this target by and target amount. Right, so if you look at the model row for these two variables, these two are target rows. So what does that mean? It means these two are not indicator variables. These two variables are response variables. Right, why we have two response variables? If we look at the data type, this target by is the binary variable, right? So it only have two levels, either 1 or 0. So 1 is for yes, 0 is for no. That means this variable is a categorical variable. And for the next response variable, the target amount, it is a continuous variable. So it is a quantitative variable. Right, so we have a categorical variable and a quantitative variable. Then we need to choose either one based on our question, right? Okay, so based on this general information, we know what? We know we have 1, 2, 3, 4, 5, 6, 7, 8, 9 input variables. We have 1, 2, 2 response variables. And we have the ID and the DEM cluster. These two variables should not be included in our analysis. Right, so if you look at our data, we first need to deal with these two variables. We should not include these two, right? So to be more convenient or not be confused, we need to prepare it. So ID, I want to exclude it, right? And then once you exclude it, the values is still there. But if you look at the left list of the variables, this variable is excluded, All right, so this one is not included in our analysis. So if you, for example, if you want the distribution, you will not see ID variable in this list anymore. Right, and then we want to do the same thing for the DEM cluster because this one is not an input variable, it is rejected. It has the repeated information with this variable, right? So we also want to exclude it. So in this option, you can also have exclude or unexclude. So for now, we exclude it, but in the future, if you want to use this variable, you want to include this one, then you can choose it to unexclude it, and then it will be still show here in the list, right? So now for our analysis, these two variables should not be included in our analysis. That's why these two variables are excluded. All right, so these ones are the general information about this data. Next, let's answer the questions. All right, so question 1, explore the data. So here, how to explore the data? Use the analyze distribution for each variable, and then only explore the variables we will use as inputs. So for this step, we have already did, right? We have already exclude the variables are not input variables. Right, the question is asking about how many input variables have the missing observations. So here I say the hint that you can compare the n for each or for each, or right click on the summary statistics and have the jump display the n number of missing observations. All right, okay, so I will show you how to do it. Right, so the question is asking that how many input variables has the missing observations. The easiest way is you just check every variable. For this variable, you have the missing observations. This one has the missing observations. This one missing observations. This one missing. This one missing. Right, so at least these 5 have the missing values, right? This one also have the missing values. This one has the missing values. And this one, I don't know, for now it doesn't have any, but you need to go until the end to check, right? So you can use this way to count how many input variables have the missing observations. Another way is to analyze and to get the distribution of every input variables, right? So we can do both all of these ones, right? And then go to the Y and then click OK. And then you can have the distribution for each variable. All right, so now how we can get the number of missing observations for each variable? There is a summary statistics table, right? It will show you the number of observations in this variable. And then if you click this, customize it, and then it will show you that right now it only show these 6 options. And then there is another option which is n missing. If you click this and then click OK, it will show you that how many missing observations in this variable. All right, so it will show you that there are 496 missing observations in this variable. Right, so of course that means this variable has the missing observations, right? This one do the same thing. Number of missing, click OK. Okay, so this is not 0, it is 706 missing observations, right? Okay, so for this variable, it doesn't show the summary statistics table. Why? Because these 2 variables are quantitative variables, right? These 4 ones are the categorical variable. You cannot have the mean of these 7 levels, right? So it doesn't make sense if you average from A to U, right? Okay. So it will directly show you how many missing observations in this variable, right? And also it will show you how many levels in this variable. All right, okay, so this variable has the missing observations. This one has the missing observations. This one is also has the missing observations. This one too, this one too, this one, yes. Okay, this variable, it says the number of missing observations is 0. That means this variable doesn't have the missing observations, right? And then this one, again, we have the quantitative variable so that we have the summary statistics table. So we just customize it. Number of missing. All right, okay, so this variable show you no missing observations, right? And then do the same thing to the last variable, right? Okay, so that means there are 116 missing observations. All right, so actually when we check all the variables, totally we have how many input variables? We have 9 input variables. And then in these 9 variables, we have these 2 don't have the missing observations. That means the other 7 variables all have the missing observations, right? So totally we have 9 because it's 1, 2, 3, 4, 5, 6, 7, 8, 9 input variables, and then we have 2 of them don't have the missing observations. So the other 7 will have the missing observations. All right. Okay, number 2, question 2. How many levels does this variable contain? It's about the gender, right? So let's look at the gender. Where is the gender? This is the gender, right? How many levels contained in this variable? You can either count 1, 2, 3, or at the bottom it will tell you how many levels in this variable it is. It contains 3 levels, right? Okay. So the answer is 3. All right, okay, next, questions 3. Do you see any unusual observations? What should we do about them? All right, so unusual observations, what does that mean? Outliers, right? Okay, so we are looking for any variable has the outliers. This one, good, right? This one, good. This one, good. This one, good. Any outliers? This one, good, 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 good. Okay, this variable has the outlier, which is this point, right? Okay, so for this variable, it has the potential outlier. That means we don't know whether it is a real outlier or not. We need to decide whether it is a real outlier or it just makes sense, right? So for this case, this variable is the total amount spent in the market. And this outlier, it shows, that's too much, right? $300,000 spent in this market. All right, okay, so what does that mean? That means for this variable, we have a unusual observation, and then what do we need to do about it? Since it is an outlier, this point doesn't make sense, right? So what do we need to do? We need to exclude it, right? So this variable the spend has an unusual high value, so that we need to exclude it. All right. Question number 4. If we are trying to predict if a person is likely to purchase the organic products or not, should we include the variable target amount in the model as an input? Why or why not? Okay, so here there are 2 questions. The first question, if we want to make the prediction about whether this person will purchase the organic products or not, then should we use this variable in the model as an input variable? So first question, should we? Of course not. Because what? Because both of these 2 variables are response variables. They are not input variables, right? So you cannot use a target amount to make the prediction about whether it will purchase or not. Then it is not a modeling problem. We even don't need to do that. We just use the target amount. If it is not 0, then yes. If it is 0, then no. If it is not 0, then the answer is yes, right? So these 2 are both response variables. You cannot use the target amount as an input variable to make the prediction about this variable, right? So first, the answer is no. Then the second question is asking why or why not. That means why we cannot include it as an input. Because if we use the target amount, can we answer this question? Can we answer whether a person is likely to purchase it or not? Of course not, because the target amount is not an input variable, right? Because it is a response variable, it is not an input variable. You cannot use it as an indicator about another response variable, right? So for this case, it will be no, the target amount is not an indicator of whether someone will buy the product. Some of you choose the first option, say no, the target amount is a quantitative variable. Okay, so here it is a reason for why we do not use target amount as a response variable. But here the question is asking why we should not include the variable target amount in the model as an input. It is not because it is a quantitative variable. We can just not use this variable as the input variable. It is not an indicator variable. All right, okay, so number 5. Construct a classification tree, use the target by as the response, and only use the inputs in the model and include split counts. All right, I don't see many of you did this step, but I still give you the credit. All right, okay, and then use the training set and the validation set. All right, okay, so let's generate the decision tree. So we are done with the histograms, right? So let's come back to our decision tree. In this is our data. We need to analyze, predictive modeling, and then partition, right? We need to choose all the input variables as the X. And then since we are asking about the classification tree, so we need to use the categorical variable target by as the Y with the response variable. right? And then what's the next thing you need to do? We need to use the validation set, right? So that if you add the validation set into our analysis, we know that the decision tree, we know where to stop splitting in our decision tree. All right, okay, so click OK. All right, so this is whatever we got, and then we need to click Go. All right, okay, once we click Go, first we'll have a kind of not colorful decision tree, and then we have a general information table for the training set and validation set, right? We have the number of observations in the training set, number of observations in the validation set, and number of splits we did in our model, right? Okay, and next it is our colorful decision tree. All right, okay, and then we have the split history, and then we also need the column contributions table, so we need to choose this one to show up. All right, and another thing is look at any group for now in the decision tree. This group just tell you how many total counts in this group, but remember our response variable, which is the target by, is a binary response variable, right? So that means either yes or no, either 1 or 0. So since this is just a total counts, we want to also show how many of them are zeros, how many of them are ones, right? So here we need to go to the display option, right? And then show split count. Right, okay, so if you choose this option, it will show you that in this group, there are 584 of them are zeros, 649 of them are ones. Right, so it will provide you more information when you want to make the decision at the end. All right, okay, so now we have the decision tree, we have the split history, we have the column contribution table, all good. And then we need to save it. Normally it is hide it, file, save as, and then here we need to change the type. Here, some of you gave me the GRP file. All right, so here I need you to know that if you send me GRP file, I cannot open it. Why? Because this GRP file only works in your computer, right? So it will only based on whatever you have processed, whatever steps you have already done, and then this is the output. But if you only give me this GRP file, I cannot open it because I don't have your previous steps. This is not the way you save the output, because this output can only be opened in your computer, not mine. It's the same thing if you want to show the output to your manager in your future company. All right, so you will have the same problem. So the better way is to save as a PNG file, save as a picture, so that you can insert it in any file, in Word or any file you want to show the output. All right, okay, so just to change the file type as the PNG file and then save it. I have already got it, so just to say yes. Okay, so this is a PNG file, include all the outputs, so you can always get it as large as possible, as large as you like, or as small as you like. All right, so this is the output so that you can save it and upload on the data analysis 3. All right, so then you will be okay with this question 5. All right, next question. How many rows of data are in the training set? So what does this question asking about? This question is asking about how many observations in the training set, right? So how many observations in the training set? This table, right? So this n tell you how many observations, right? So how many observations in the training set? 5009, right? That's it. 5009. All right. Okay, next one. Question 7. How many terminal nodes does the final model GMP choose to contain? All right. Okay, so let's look at this. Our output will be easier to count because our output is too large, and then you need to go to left or to the right. It is not easy to count. Terminal nodes, that means any group don't have any subgroups or branches, right? So we just count how many terminal nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So we totally have 15 terminal nodes. All right, number 8, what variables or used in the model? So here I have the hint, use column contributions. Let's look at our output. Contribution, column contribution table here. All right, so in the previous video or the introduction video, I have already talked about this column contribution table, right? So it will tell you that in this data analysis, which variable contributes the most, how many variables contributed in this analysis, right? So for here, that means only these three variables contributes to our analysis. The other ones, the other 6 variables, the other 6 input variables have 0 contributions to our analysis, right? So that means will be the age. What's this again? The affluence. Yes, affluence grade, right? So it will be age, affluence, and gender. Only these 3 variables are included in our analysis, right? So it will be number 8, right? So it will be affluence, gender, and age. Only these 3 are included in our model. All right, okay. So another way to see if I don't have this column contribution table, how you can count. That means you need to look at your decision tree and see which variable is used, right? You use the age, you use the affluence, right? You use affluence, gender, right? So the gender, affluence, and age. Is there any other variables we used to split the groups? Actually, no. Right, so we just used these 3 variables to make these splittings, right? Okay, so this is another way to determine which variables are used in the model. Right. The last question, find the characteristics of the most likely purchased of organic data. Right. Most likely purchase of the organic data. That means what? That means which terminal nodes have the most ones, right? 1 means yes, that means purchased, right? So it will be, we just look for the terminal nodes, that which terminal nodes contains the most ones, right? So this one, 54 contain ones, 54 purchased. This group, 175 purchased, right? 44, 209, 73, 94, right? Okay, so that means until here, the most ones is this group, 209, right? Okay, so let's continue. Did we did this? Okay, we just did this part, right? So 26, the most ones for now is 206, right? So 113, 31, 37, 142, 64, 58, 59, 41, and then we are done with the decision tree, right? So that means which group have the most ones? This 209, right? Okay, so how to describe this group? How to describe this group? Remember I said if you want to describe this group, you need to go from the bottom until the end, until the top, right? So actually, if you want to describe this, you need to have the age less than 40 and gender is female and the affluence less than 12 and the age is less than 45. Okay, I don't think you will have these two any problem with these two levels. It's just the female and the affluence is less than 12. What about these two? If we want to describe this group, that means the age need to be less than 40 and it need to be less than 45. So if you want to combine these two levels, the age should be less than 40 or less than 45. A number should be less than 40 and less than 45. That means this number should be less than 40. Because what? Because, for example, if I have a person with the age is 43, then this person is in this group? Of course not. It will be less than 45 and larger equals to 40. It will jump to the other groups, right? So that means if you want to describe this group, you need to combine, it need to be both, satisfy both conditions, less than 40 and less than 45. So of course it will be just less than 40. If you don't understand here, you can just draw the number axis, right? 40 and 45. If it is less than 40 and less than 45, it is the same thing that the age should be less than 40. All right, so now how to describe this group? It will be less than 40, female, and less than 12. Right, so which one? Female less than 40 and affluence is less than 12. So it will be this option. All right, okay, so we are done with all these 9 questions in the data analysis 3. I thought this one is easy one because it's just the basic steps for the first 3 or 4 questions is just about the preparations or the understanding about the data set. All right, okay, so I think after this video you should be good with the decision tree and you should be familiar with the question type in the final exam regarding the decision tree. It will be very similar questions, but I will not ask you to use the JUMP to generate the output. I will give you the output, and then based on the output you should be able to answer this kind of questions. All right, okay, so that's all I want to talk about the data analysis 3. All right, just let me know if you have any further questions.